Welcome to G Fun Facts Online, your go-to source for the most fascinating breakthroughs in science and technology. Today, we're diving deep into a topic that could revolutionize our energy future: producing hydrogen, the clean fuel of tomorrow, directly from seawater. Imagine a world where we can tap into the vast oceans to power our lives sustainably. It sounds like science fiction, but researchers are making incredible strides to turn this into reality. Now, the idea of green hydrogen isn't entirely new. It's typically made through a process called electrolysis, which uses electricity to split water into hydrogen and oxygen. Simple enough, right? Well, there's a catch. This process usually demands highly purified, deionized water. If you want to use seawater, you first have to go through desalination, a costly and energy-guzzling step to remove all the salts and impurities. Think about it. Desalination plants can cost hundreds of millions of dollars to build and run. That's a significant hurdle for widespread green hydrogen production. But what if we could skip desalination altogether? This is where the really exciting science comes in. Researchers are developing groundbreaking technologies for what's called direct seawater electrolysis, or DSE. This means extracting hydrogen straight from seawater, no desalination, no added chemicals. This could drastically simplify the process and slash the costs of green hydrogen. Of course, electrolyzing seawater directly isn't a walk in the park. Seawater is a complex cocktail of various ions, especially chloride ions. These little troublemakers can lead to nasty side reactions, like producing chlorine gas instead of just oxygen. Not only is this inefficient for hydrogen production, but chlorine gas is toxic and can corrode the equipment. Then there is biofouling, microorganisms in seawater that can clog things up, and the precipitation of minerals like magnesium and calcium hydroxides on the electrodes, which can also hinder performance. So how are scientists tackling these challenges? It's all about ingenious engineering. Firstly, they're designing advanced electrodes and catalysts. These new materials are more resistant to corrosion and are super selective, meaning they encourage the good reactions, making hydrogen and oxygen, and suppress the bad ones, like chlorine evolution. For instance, researchers at the University of Sharjah have created a multi-layered electrode. Think of it as a tiny, protective, and highly reactive zone right where the action happens. It's shown it can produce hydrogen at industrially relevant rates with an impressive 98% efficiency for over 300 hours without degrading. Other cool materials include nickel polysulfide-based electrocatalysts and layered catalysts like nickel iron hydroxide, which also efficiently split seawater without that unwanted chlorine gas. Secondly, scientists are rethinking the design of electrolysis cells. New configurations, like bipolar membrane cells, help minimize chloride ion movement and create a less corrosive environment. They're also developing specialized membranes that act like bouncers at a club, letting hydrogen ions through while blocking unwanted ions like chloride. And thirdly, there's electrolyte engineering. Sometimes, simply adding alkaline electrolytes, like potassium hydroxide, to untreated seawater can help suppress chlorine production and boost oxygen evolution. So why is all this effort to skip desalination worth it? The benefits are massive. First, reduced costs and energy consumption. Cutting out desalination means lower capital and operational costs, making green hydrogen more economically competitive. Second, we're talking about an abundant water source. Seawater covers over 96% of the world's water. Tapping into this can ease the strain on our precious freshwater resources, which are dwindling in many regions. Third, a smaller environmental footprint. Direct seawater electrolysis facilities would be more compact and avoid the problem of brine discharge from desalination, which can harm marine life. Fourth, this technology is perfect for pairing with offshore renewable energy. Imagine offshore wind farms directly powering seawater electrolysis plants to make green hydrogen right there on site. This creates self-sufficient energy hubs. And finally, it enables decentralized hydrogen production in remote coastal areas, islands, and places without freshwater infrastructure. And the progress is real. Several teams are making waves, The University of Sharjah's electrode we mentioned is a big deal. RMIT University in Australia has developed a special catalyst designed specifically for seawater, claiming it's simpler, more scalable, and cheaper. Researchers led by Cornell University have even created a hybrid solar-powered device that not only produces green hydrogen from seawater, but also generates drinkable water as a bonus. They estimate this could bring green hydrogen costs down to just $1 per kilogram within 15 years. Perhaps one of the most exciting demonstrations comes from a collaboration between Shenzhen University, Sichuan University, and Dongfang Electric Corporation. They successfully tested the world's first direct seawater electrolysis technology powered by offshore wind. Their floating platform operated stably for over 240 hours in a real marine environment, producing hydrogen with 99.9% to 99.99% purity. That's incredible. Now, it's important to keep a balanced view. Some experts point out that direct seawater electrolysis still faces challenges like long-term stability, electrolyzer durability, and consistently matching the hydrogen purity you get from systems using purified water. Some techno-economic analyses also suggest that modern desalination is already quite cost-effective, and the energy savings from direct seawater electrolysis might be less significant than hoped when you look at the big picture of hydrogen production costs. Despite these valid points, the potential benefits, especially for specific regions and applications, are too significant to ignore. The research is pushing forward, focusing on better catalysts, more stable electrodes, and more efficient systems. The dream of cleanly and cheaply producing hydrogen from the most abundant water source on Earth is a powerful motivator. As offshore renewable energy projects expand, integrating effective direct seawater electrolysis technologies will be a key piece of the puzzle for achieving truly sustainable hydrogen production and helping us meet our global environmental goals. The journey to a hydrogen-powered future is complex, but innovations like direct seawater electrolysis are lighting the way. With continued research and development, this breakthrough technology could truly revolutionize how we produce energy, making it cleaner, more accessible, and more affordable for everyone. That's all for today's episode of G Fun Facts Online. Join us next time as we explore another amazing facet of our world. Thanks for listening.